Okie doke. About that time? Well, good afternoon, everybody. Hope everybody is doing well today. This is Psych. Maybe it is Psych 301. Research, design, and methodology. The final chapter. This is the final exam. Exam review. So, this is the last lecture for the whole class, so I bet we're all happy about that. I'm really sorry we had to do the end of the class this way. I wanted to apologize one last time because I'm embarrassed about it. I wish we didn't have to do it this way. I know it's not optimal, but you all have done just a great job adapting to it. I really appreciate how well you've done. Specifically, I didn't know how this thing where we took photographs of the stats quizzes and sent them in would work, and it worked great. And you all did a great job with that, and I'm very appreciative. So I appreciate all the accommodations that you've given us and that you've been patient with the class, and I'm sorry I didn't get to see you all again. So I wanted to say several things before we start. First is I got a grown-up picture of Rosie to end with, not a puppy picture. So that's more what she looks like now. And this picture was actually in the Des Moines Register. She was in the Corgi races at that racetrack in Des Moines Prairie Meadows. So they have Corgi races a couple years ago. They did. And then they had some of the pictures of the Corgis in the Des Moines Register. So this was a professionally taken photograph. Okay, and so I wanted to talk a little bit. This is the last class where we're going to talk to you, so I wanted to say goodbye and tell you I enjoyed having you as a class, the times that we did meet, and I hope you come back to Iowa State, and I hope we have class in the fall. For those of you who might be interested in taking another one of my classes, I teach Psych 312, which is Sensation and Perception. And I'm going to teach that in the fall. And then I teach Psych 411, Evolutionary Psychology. And this is the first time they've let me teach it in quite a few years, so I'm excited about that. That will be in the spring next year. Next spring of 2021 is when that will be. So I'd love to see you in some of my other classes. Okay, well, how did the vote come out? So the format of the exam will be identical to midterm number 2. You have 40 questions to answer in 30 minutes. So I had the vote on what format of the exam to have because some people had complained about the half-hour exam, but most people liked it. The vote for having the final be like midterm number 2, there's almost twice as many votes for that. It was 64% to 36%, I think. So we're going to do it the same way as midterm number 2. And I don't think that was a horrible test. People did very well on the test, actually, so I think it'll be fine. The only difference now is each question is worth 2 points. Instead of 1, because the final is worth 80 points, but it's going to be 40 questions in 30 minutes still. Okay, don't know what else to tell you other than I expect the mix of questions to be very similar to midterm number 2. So there were some memorization questions at the beginning, but then there's going to be a higher percentage of questions you have to think about, like the ANOVA summary table interpretation questions, research evaluation questions, and so forth. So I expect the mix of questions to be very similar to midterm number 2. The whole thing is going to be pretty similar to midterm 2. Now I'm going to put a announcement up about the final exam. But if you saw the final exam schedule, our test was scheduled to be Wednesday afternoon of finals week. That's Wednesday, May 6th. So the final exam will open at noon on Wednesday, May 6th. And it will close at 1 p.m. on Thursday, Thursday, May 7th. So essentially you got 23 and a half hours to start the exam. Last time to start the exam is 12:30 p.m. on Thursday, May 7th, like I said. So once you start, you have half an hour to complete the exam. You won't be able to go back to previous questions, so once you answer the question, then it'll move on. The average to take that exam was 22 minutes out of 30, and that seems pretty good to me. That's about what I would expect, so I don't think it was a terrible exam, and I kind of like the way we did it, so I was glad that most people wanted to do it that way again. Okay, well, the goal today is to get you shipshape for the final. We are mostly going to be review over things, but we have one new skill that we didn't have before, and that is identifying the survey sampling technique. So we'll do some of those later. But let's start out with, I want to start out with experiments and investigations. Experiments and investigations. So there could be questions in which I describe how somebody did their research, and you have to identify the independent variable, the dependent variable, and whether the research was an experiment or an investigation. And remember, the key elements you have to have an experiment are the researcher has to manipulate the independent variable, and there has to be random assignment. All right, so let's try one of these. All right, we're interested in whether men or women drink more coffee. We randomly select 10 men and 10 women to report how many cups of coffee they drank in the past week. We then want to compare the means for the two groups. All right, first thing I'm going to ask you, I'm going to start easy. What is the dependent variable? The dependent variable is how many cups of coffee they drank in the past week. That's what we're measuring. What is the independent variable? So X is the independent variable. And is this an experiment or an investigation? Well, it's an investigation. We didn't randomly assign people to be men or women. In fact, if men versus women is our independent variable, it can't possibly be a experiment. So that is definitely an investigation. All right, let's try another one. We're interested in whether a particular cold medicine is effective. We randomly select 20 people who have colds and randomly assign half of them to receive the cold medicine, the other half to receive a placebo pill. We then ask them to rate how well they feel on a 10-point scale, where 1 is very bad and 10 is very good. We're interested in whether the mean ratings differ. Okay, so first question, what is the dependent variable? Well, the dependent variable is their wellness ratings when they rate how well they feel. That's what we're measuring. What's the independent variable? Well, the independent variable is the type of treatment they received, whether they received the placebo treatment or the cold medicine. And now, is this an experiment or is it an investigation? This one is an experiment. We randomly assign people to the levels of the independent variable, and we, the researcher, manipulated the independent variable, so that's an experiment. So there may be something like those on the test. What I'd recommend you do is, it's easiest, I think, if you're identifying the independent and dependent variables, to identify the dependent variable first, what they measured, so you might want to proceed that way. But there'll probably be something like that on the test. Okay, well now let's do the single subject experimental designs and quasi-experiments. So these were frequently missed on the midterm, and so I want to try these to make sure we got them down. Before we begin, what's going to happen is there's going to be a description of how somebody did their research. You have to identify what type of, which one of the three single subject experimental designs, or which one of the 4 quasi-experiments we learned it is. So let me review real fast before we start. The 4 quasi-experiments you need to know are the single group pre-test post-test design, the interrupted time series design, the non-equivalent before-after design, and the ex post facto design. Those are the 4 quasi-experiments. The 3 single-subject experimental designs that you need to know are the reversal design, the multiple baseline design, and the multi-element design. All right, here we go. We have 5 different treatments we think will reduce our dog from destroying our furniture. Per week, we introduce a different one of the 5 treatments every hour and measure how much furniture destruction the dog does during that time period. What sort of design is being used here? And the answer is this is a multi-element design. That's a multi-element design because we had several different treatments for one behavior. It's a single subject design because we only had one dog. So that is the multi-element design. All right. We have a new vocabulary improvement program. We take a group of people who want to improve their vocabulary and give them a vocabulary test once a week for 4 weeks. We then introduce our vocabulary building treatment. After the treatment, we again test each of the participants' vocabularies once a week for 4 weeks. What sort of design is being used here? All right, so we had several tests of the DV prior to treatment and several tests after the treatment. So that's the interrupted time series design. All right, next on the hit parade. We want to test a new weight loss program. We take a group of 20 people who want to lose weight and measure how much they weigh. Then a treatment's introduced to reduce their weight. After treatment, they are weighed again. What sort of design is being used here? All right, well, it must be a quasi-experiment because we're testing more than one subject. We're testing a group of subjects. And they were tested once on the DV, then given our treatment and tested once on the DV again. And that's the single group pre-test post-test design. Single group pre-test post-test design where subjects are just measured once before the treatment and once afterwards. We're interested in whether being in a state that's undergone financial problems increases the amount of unemployment in the state. Data is collected from states about unemployment rates for the year prior to and the year after major recessions have hit the state economy, and the 2 values are compared. What sort of design is being used here? Okay, well, we're studying an event that occurred in the past, and we're using archival data to do that, so that's the ex post facto design. Ex post facto. Don't do that. Ex post facto design. When you're using archival data to study an event that occurred in the past. All right, next. We're interested in whether our new method for stopping people from smoking is more effective than the old method. We have 2 groups of people who are not randomly assigned to conditions. One of the groups lives in Cedar Des Moines and the other lives in Cedar Rapids. We measure how many cigarettes per week each group smokes prior to giving them any treatment. We then give our treatment to the Des Moines group and give a placebo treatment to the Cedar Rapids group. After the treatment's been administered, we measure the number of cigarettes per week each group smokes again and use the difference in scores between the first and second measurements as our dependent variable. What sort of design is being used here? Okay, well, what we got is 2 separate groups of subjects who are not randomly assigned. We gave them a pre-test before our treatment. We gave 2 different treatments to the groups and then gave a post-test afterwards. And then the dependent variable is their post-test score minus their pre-test score. And all of those are part of the non-equivalent before-after design. Non-equivalent before-after design. It should stick out like a sore thumb because it's the only one that has 2 separate groups of subjects. Next on the hit parade, we have a single child who cannot sit still, and we're interested in whether we can improve the child's ability to stay in his seat. We first measure the number of times the child gets up from his seat during a day. Then we introduce our manipulation. We give an electric shock to the child every time he gets up and measure how many times the subject gets up from his seat during a day again. We then remove the treatment and again measure how many times the child leaves his seat during a day. We then reintroduce the treatment and see again how many times he leaves his seat during the day. What sort of design is being used here? Well, we know it's a single subject experimental design because we only got one subject, and this is where we measure the dependent variable in the absence of any treatment, then introduce a treatment and see if the dependent variable is effective. Then we remove the treatment to see if behavior reverses to what it was before, and then we reintroduce the treatment. And so those are the hallmarks of the reversal design. That's a reversal design. Okay. One more of these, and then we will move on to something else. Why did it do that? All right, it went bold. Take 3 measurements on a single schizophrenic patient. The amount he screams, the number of voices he hears, and the amount of time he spends catatonic. We introduce treatment we think will reduce his number of screams. After introducing the treatment, compare any changes in the number of screams he makes to changes in the other 2 variables. We then remove the scream reduction treatment and introduce a treatment for reducing the number of voices he hears, again measuring any changes relative to any changes in the other 2 factors. Then we withdraw that treatment and introduce a treatment for the amount of time he spends catatonic, and again compare any changes in this variable to the other 2. What sort of design is being used here? All right, it's a single subject experimental design because we only got one subject, and what we're doing is we're measuring 3 different behaviors and then introducing a single treatment for each. And so that's the multiple baseline design. Multiple baseline design. Remember, multiple baseline as multiple behaviors, and that's what we've got here. Okay, did not do that. Okay, so those were the identifying quasi-experiments and single subject designs. All right, I think the next thing we need to do is let's work on the new thing that we haven't had before, and that's the survey research sampling techniques. So how this will work and how it'll be on the test is I will describe how somebody did their research, and then you have to tell me which of the survey sampling techniques we discussed they were using. So let's review. The survey sampling techniques we discussed are convenience sampling, quota sampling, simple random sampling, stratified random sampling, and multi-stage sampling. Those are our sampling techniques. All right, let's try a few of these. A researcher gets a list of all the people who belong to the Future Farmers of America. She divides the list into people who've been members of the organization for 1 year, 2 years, or more than 2 years. She randomly selects 15% of the people in each group to tell her what their future career goals are. What sort of sampling technique is being used? Let you think about that. Well, the critical things to note are we've got a random selection here, and so remember, convenience and quota sampling do not have random selection components. So we know it's one of the 3 types of probability sampling. And it looks like they're taking the whole population and dividing it into different demographic groups and then randomly selecting a certain percentage of people from each group. And so that is stratified random sampling. Stratified random sampling when you do that. All right, let's try another one. Researcher gets a list of all the people in a city. She randomly selects 15% of the people on the list and asks them whether they like potato chips or nachos better. What sort of sampling technique is being used? All right, she's using random selection, so we know it's not convenience or quota sampling, right? Because they don't have random selection. She got a list of the whole population, all the people in the city, and randomly selected a certain percentage for questioning. So that is simple random sampling. Simple random sampling. Okay, next. A researcher wants to know if people prefer Coke or Pepsi. She asks the first 200 people she sees which drink they prefer. What sort of sampling technique is she using? All right, well, she's just taking people who are available without regard to their characteristics. So that's convenience sampling. Convenience sampling, when you're sampling subjects without regard to their characteristics and aren't doing it randomly. All right, next on the hit parade. A researcher gets a list of all the colleges in America. She randomly selects 50 of them from the list and gets the names of all the people enrolled at each of the 50 colleges. From each of her 50 lists, she randomly chooses 15% of the people and asks them whether they enjoy football, baseball, or basketball more. What sort of sampling technique is being used? All right. So she had a first random selection stage where she selected natural groups, in this case colleges. And then in a second random selection stage, she selected people who were in the groups that she selected in the first stage. And that is characteristic of multi-stage sampling. That's multi-stage sampling, where there are two random selection stages, one where you select natural groups, and then a second one where you select people in the groups that you selected in the first stage. Last one of these. Research is interested in whether people prefer summer, spring, autumn, or winter. The researcher decides to ask 10 people in their teens, 10 people in their 20s, 10 people in their 30s, and 10 people in their 40s which season they like best. She asks the first 40 people she encounters to meet these characteristics. What sort of sampling technique is being used? That is quota sampling. Quota sampling. She decided what the demographics of her sample that she wanted beforehand, and then just took the first people she met that met those characteristics. Okay. All right. So I hope those aren't too hard. People usually do pretty well on those on the test. All right. Let's do a what type of stats analysis. Okay, so we have 10 tests that we know now. We've added a new test since midterm number 2. That's the test of independent frequency, as you could call it the chi-square test if you want to. So I'm going to give you, just like we've had on the previous tests, a description of how somebody did their research. You have to tell me what sort of stats analysis is appropriate for that research. Here we go. Do dogs, cats, and ferrets differ in the amount of food they consume? The total amount in pounds of food consumed in a week is measured for 15 randomly selected dogs, 15 randomly selected cats, and 15 randomly selected ferrets. We're interested in whether the mean amount of food consumed differs among the three groups. What's the appropriate sort of stats analysis? Okay, well, it looks to me like we got 3 levels of the independent variable, dogs, cats, and ferrets. We have, of course, different animals at each. You can't be a dog or a cat and a ferret. So we know we got different subjects at each IV level. So we're comparing the means. So it's a between subjects design with more than 2 levels where you're comparing the means. That's the between subjects one way ANOVA. Hey, between subjects one way ANOVA there. Okay. Next on the hit parade. Yep. We are interested in whether people prefer writing with pencils or with pens. We randomly select 340 people and ask each of them whether they prefer writing with pencils or pens. We're interested in whether the number of people preferring pencils is reliably greater or less than the number preferring pens. What's the appropriate analysis? All right, so we asked people to choose between pencils and pens. We're looking at whether the number of votes one got was different from the number of votes another got. So that is the test of independent frequencies. Okay, because we were comparing the number of people who chose one versus the number who chose another. So that's the way to identify that one. You're not comparing means. You're not comparing variances. You're not looking for a relationship. What you're doing is comparing the number of people who chose one alternative to the number who chose another. So that's the test of independent frequencies. You want to know if Iowans know more about world events than Minnesotans? You give a world events test to a group of 350 randomly selected Iowans and 400 randomly selected Minnesotans and want to do an analysis to see if the mean scores differ on the test. What sort of analysis is appropriate? All right, let's see. We got two levels of our independent variable, Iowans and Minnesotans. And you can't be both an Iowan and a Minnesotan, so we know each subject was assigned to one level or the other. And we're comparing the means, so that is the between subjects t-test. Between subjects t-test. You don't have to be able to identify the version on this one. So that's all you have to say for that. All right, next. The test is done to determine if people like Coke, Sprite, or RC better. 12 subjects are given tastes of Coke, taste of Sprite, and taste of RC, and rate how much they like them on a 10-point scale where 1 is poor and 10 is excellent. We want to know if the mean ratings for Coke, Sprite, and RC are different. What's the appropriate analysis? Okay, we got 3 levels of our independent variable, Coke, Sprite, and RC. All the subjects taste all 3 of the drinks and rate each of them, so that's what tells us it's a within subjects design, because the subjects are receiving all 3 IV levels. And so if we got 3 levels, we're comparing the means, and it's a within subjects design. That's the within subjects one-way ANOVA. Within subjects one-way ANOVA, because we got 3 levels in within subjects design, and we're comparing the means. An experiment was conducted to determine the effects of vitamin consumed, vitamin A versus vitamin B, and hours of training, 8 hours versus 16 hours on a motor control task. 24 subjects are randomly assigned to one of the 4 treatment combinations, and their score on a motor control task is recorded. We're interested in the effects of the variables on mean performance. What's the appropriate sort of stats analysis? All right, this one should stick out like a sore thumb because we got 2 independent variables, right? Vitamin consumed, it has levels vitamin A and vitamin B. And hours of training, it has levels 8 hours and 16 hours. The only one we know with 2 independent variables, is the between subjects factorial ANOVA. Between subjects factorial ANOVA, because they're analyzing the means from an experiment that has more than one independent variable. All right, next one. You're interested in whether outside temperature and amount of electricity consumed are related. You get the outdoor high temperature in Ames and Fahrenheit for every day during a calendar year, and also compute the number of kilowatts consumed in Ames each day, and want to determine if there's a relationship between the two. What's the appropriate analysis for this data? All right, it's asking whether there's a relationship between these 2 continuous variables, and so appropriate analysis would be a correlation. An experiment is conducted to determine if people's ability to remember nonsense syllables changes depending on the temperature of the room. 10 subjects are read lists of nonsense syllables in a room that has a temperature of 60 degrees and also in a room that has a temperature of 95 degrees. In each room, the subject's memory for the nonsense syllables is measured. We're interested in whether the means at each temperature are reliably different. What's the appropriate analysis? All right, so we have 2 levels of the independent variable, the 60-degree room, the 95-degree room. Everybody got both of the levels, and we're comparing the means. So this is a within subjects design that has 2 levels, and you're comparing the means. It's within subjects t-test. Within subjects t-test. We're interested in whether having music in the background affects the variability in performing a memory task. Subjects are randomly assigned to be in one of 2 groups, a music group or a silence group. We want to know if the variances in the memory test scores for the 2 groups differ reliably. What's the appropriate analysis? All right, so we had 2 groups of subjects. Everybody was assigned to one level or the other, and we're comparing the variances. And so if you got 2 levels, and it's a between subjects design, and you're comparing the variances. That is the between subjects variance test. Between subjects variance test. You hear on TV, the average person in Korea goes to 1.3 sporting events per year. We randomly select a sample of Americans and ask them how many sporting events they went to last year. We are interested in whether the mean number of sporting events attended is different for people in Korea than for people in America. What is the appropriate sort of analysis? All right, so we got a number here, a single number, a standard where we don't have the sample, and then we're going to take a sample of Americans and compare it to this number. Well, that is test of a single sample mean. Test of a single sample mean, comparing the mean of one sample to a number where you don't have the sample. All right, last one of these. We're interested in whether sugar affects the variability in people's motor control. 6 subjects eat a cup of sugar and perform a motor control task, and later these same 6 subjects eat a teaspoon of sugar and perform the same motor control task. We're interested in whether the variance in the cup of sugar condition differs from the variance in the teaspoon of sugar condition. What is the appropriate analysis? All right, let's see. Well, we had the subjects. They did both of the conditions, and we had 2 levels, and we're comparing the variances. So if they did both conditions, that's within subjects design. And if we're comparing the variances, then that's the within subjects variance test. Within subjects variance test. All right, so those are the 10 tests that you have to know. There is a section on the front page of the Canvas site that has a bunch of those all 10 problems for you to try, and so you can practice there as well. All right, next thing I want to do is let's do a few research evaluation questions. I imagine there'll be quite a few of these on the test next week. So what these are going to be like is I'm going to describe people, describe how somebody did their research, and the conclusion they reached on the basis of their research. You have to tell me if the conclusion is justified. Here we go. We want to know if drinking alcohol will affect people's bowling performance. We decide to use a within subjects design. We have 20 people first bowl a game without drinking any alcohol, then we have them each drink a 6-pack of beer, and then have them bowl again. We find the second time they bowl, they get reliably lower mean scores than they did the first time. Conclusion is drinking alcohol resulted in poorer bowling performance. Is that conclusion justified? All right, well, it's a within subjects design, so everybody got both levels of the independent variable, but remember, when you do a within subjects design, you have to have some form of counterbalancing to prevent practice effects. So I would say for this one, the obvious example is practice effects. That is, the people may have gotten tired from the first time they bowled, and so they were worse the next time they bowled because they were tired. And so usually you think of practice making you better, but in this case, practice could make you worse. So that would be no, I guess, not justified, no, comma, practice effects is what I'd say for that. All right. Next on the hit parade. Stop it. Just a second here. All right. We're interested in whether our new program for improving GRE verbal scores is effective. We take a group of 40 people who got very low scores in the GRE verbal section the first time they took it. Mean score equals 300. And randomly assign half of them to receive our treatment program, and randomly assign the other half to receive a placebo treatment. Then have the people take the GRE again and find the group which received our treatment program had reliably higher mean scores in the verbal section than the group that received the placebo treatment. Conclusion, our treatment program caused an improvement in GRE scores. All right, this is a causal conclusion here, and so to draw a causal conclusion, you must have done an experiment. Did they do an experiment? Well, yeah, they did random assignment. They randomly assigned half the people to get the treatment program, randomly assigned the other half to get a placebo treatment. They manipulated the IV, which is the second criteria. We decided who was going to get the placebo treatment and who was going to get the treatment program. We found a reliable difference, so the answer here is yes, this is justified. All right, I get a lot of people, if I ask them this, would say no, because of regression to the mean. Because look, you took a bunch of people with really low scores. Well, that's right. We did take people with low scores because that is the people we want to help with our new training program. But it's okay to take people with low scores provided you have a control group. And they did have a control group here. They randomly assigned half the people to get the treatment program, half the people to get to the control group. So this one is fine on that. It's not a problem. That's how you control for regression to the mean, is by having a control group. All right, let's try another one. Want to know if swimming can lower people's blood pressure. We randomly select a group of people on college swim teams, swim an average of 30 hours per week, and also randomly select a group of college students who are not on swimming teams. This group swims an average of half an hour per week. And measure the blood pressure for both groups. We find the swimmers have reliably lower blood pressure than the non-swimmers. Conclusion is swimming leads to a reduction in blood pressure. All right. So is this conclusion justified? We got a causal conclusion because it's saying swimming leads to reduction in blood pressure. That's the same as saying that it causes it, because it's saying if you swim more, then your blood pressure will go down. So we must have done an experiment. An experiment has random assignment. Did we randomly assign people to be on college swim teams and randomly assign people not to be on swim teams? Well, no. We randomly selected people from the swim teams and randomly selected people who weren't on the swim team. And those two groups differ on a lot of things other than how much they swim. They probably differ on their diet and maybe their age or other things as well. And so, no, a causal conclusion was drawn without random assignment. Okay, or you could have said causal conclusion was drawn, but they didn't do an experiment. There we go. No, a causal conclusion was drawn without random assignment, or a causal conclusion was drawn although they didn't do an experiment. Both are just fine. Okay, next. We're interested in whether people can remember more information if they study in a quiet environment than if they study in a noisy environment. We randomly assign 50 subjects to be in either a noisy environment or a quiet environment. Each group of subjects reads the same magazine article and are told that they will be tested for their memory of its contents later. Subjects are given half an hour to read the article, and then they're each given a test with 20 questions to determine how much they remember. Group in the quiet environment gets an average of 19 out of 20 questions right, while the group in the noisy environment gets an average of 18.9 out of 20 questions right, and the difference between the means is not statistically reliable. Conclusion is the amount of noise in a study environment has no effect on the amount people remember from magazine articles. Is that conclusion justified? All right, well, we don't even have to really look at the whole problem here. We just have to look at the conclusion. The amount of noise in a study environment has no effect on the amount people remember from magazine articles. Well, what it's saying is we've proved that the IV has no effect on the DV, and no, you really can't conclude that. All we can say is that the data we collected provide no evidence that those variables have an effect. But you can never conclude the IV has no effect on the DV just because you might have not run a powerful enough experiment to find the effect. So the correct answer here is no, can't prove the null hypothesis. Can't prove the null hypothesis. You can never conclude that the IV has no effect on the DV. All right. And why this is all in bold, I have no idea, but we will change that. Interested in whether the Ames paper or the Des Moines paper has better coverage of foreign affairs. We randomly select 12 people who subscribe to the Ames paper and 12 people. Let me change that. People who subscribe to the Des Moines paper and have each group take a test on current foreign affairs. We find that people who subscribe to the Ames paper have reliably higher mean scores in the foreign affairs test than people who subscribe to the Des Moines paper. Conclusion: people who read the Ames paper know more about foreign affairs than people who read the Des Moines paper. Okay, well, the first question is this a causal conclusion? Does the conclusion say that reading the Ames paper is what causes those people to have know more about foreign affairs? And the answer is no. It doesn't say that at all. It's just saying one group of people knows more about foreign affairs than the other group of people. We're not saying why. There could be lots of differences between people who subscribe to the Ames paper and people who subscribe to the Des Moines paper other than the paper they subscribe to, like probably the Ames people live in Ames and the Des Moines people live in Des Moines. So this is actually okay. Yes, this is justified. The reason is we randomly selected people from the two populations we were comparing, people who subscribed to the Ames paper and people who subscribed to the Des Moines paper. They showed a difference, a reliable difference in their mean score on the foreign affairs test. So yes, we are justified in saying one group of people knows more about foreign affairs than the other. That one's okay. All right, here's one involving correlation. We want to know if people who get high scores on the ACT get better grades in college than people who get low scores on the ACT. We randomly select 300 college students and let's just take out the ask, get their ACT scores and their GPA. Perform a correlation on the data and find a reliable positive correlation between ACT scores and GPA. Conclusion: people with high ACT scores tend to have higher grades than people with low ACT scores. First question: is this a causal conclusion? No, it is not. It's just saying this one group of people tends to be higher on this variable, their grades, than this other group of people. It's not saying it's the ACT score that caused their better grades, and indeed it would kind of be crazy to say that it caused them. And so if you find a reliable positive correlation between ACT scores and GPA, what that means is as ACT scores go up, GPA tends to go up. So yes, this is justified. This one's justified. It's not a causal conclusion, and it correctly states the relationship that they found. So that one is A-OK. Next one. We're interested in whether the tutoring program at the math classes for a university is effective. Let's take this off. Take a group of people who flunked their first calculus test with an average grade of 53%. We assign them tutors to help them prepare for the second test. On the second test, the average grade increases to 71%, which is a statistically reliable improvement. Conclusion: the tutoring program is effective in improving people's grades. So we're saying that the program works to improve people's grades. That is a causal conclusion. Well, let's see. We took the group of people that had really low grades, and then we tested them another time, and they got higher. And so I think the obvious answer to this one would be no, regression to the mean. Notice how this one is different than the last one. We did one earlier where we had people who did really bad on the GRE. But there what we did is we took those bad people on the GRE and randomly assigned them to a treatment group or a control group. We did not do that here. And so that's why regression to the mean would be a good answer. I would also take no, comma, practice effects, and then I would take no placebo effects on this one as well. But I would say the best answer, I think most obvious one, is regression to the mean. That's what I would go with if I were you on that one. All right, last one on these. We've developed a new training program to improve people's memory. We randomly assigned 60 people to be in one of two groups. An experiment group who receives our new training program and a control group who receives a training program we know is ineffective in improving memory. After training, each group is given a list of 30 words to study for 10 minutes. After studying the list, subjects are told to write down as many words on the list as they remember. We find the group which received our new training program remembers an average of 24 words, while the control group remembers an average of 15 words, and this difference is statistically reliable. Conclusion is the new training program is effective in improving people's memory. Well, is this a causal conclusion? It is. It's saying that the program works to improve people's memory, so it's saying it's causing an improvement. To conclude a causal relationship, you have to have done an experiment. And so an experiment has random assignment, and I had random assignment. Well, yeah, half the people were randomly assigned to get the training program, and half the people were randomly assigned to get the placebo program. To have an experiment, the researcher has to manipulate the IV. Did the researcher manipulate the IV here? Yes, they did. We're the ones who decided who was going to get the training program and who wasn't. So this one is A-OK. So yes, it is justified. Yes, it is justified. This is just a classic case of a classic experiment. All right, well, that's it for the research evaluation questions. Now we've got a last skill that we have to do is I want to do some of the ANOVA summary tables. So let's do an ANOVA summary table. Okay. So here's an ANOVA summary table from a particular experiment, and I'm going to ask you potentially the same 6 questions that I asked you last time. So first question I could ask you about the ANOVA summary table is what sort of ANOVA was done to generate the table? And so for this table, we got 4 lines here. We got a subjects line, and we got an error line. And you only get the subjects and error line, and only 4 lines in the within subjects, one-way ANOVA. So this is a within subjects, one-way ANOVA here. Second question is, how many levels did the independent variable have in this experiment? How many levels did the independent variable have in this experiment? Well, here's the independent variable line. That's drink type. And so we need to go over to the degrees of freedom. We'll do this. Degrees of freedom column. And so remember, your degrees of freedom is the number of levels minus 1. So the number of levels is going to be the degrees of freedom plus 1. So 4. Drink type had 4 levels because you add 1 onto 3 to get 4. All right, next question I could ask. Was there a reliable effect of the independent variable in this experiment? Was there a reliable effect of the independent variable in this experiment? Well, p is greater than 0.05 here, and when p is greater than 0.05, that means no, there was not a reliable effect of the independent variable in this experiment. All right, next question I'd ask you. The F ratio here is 1.44. 1.44. How many degrees of freedom does that F ratio have? How many in the numerator? All right, so for the numerator degrees of freedom, you go on the same line. So it has 3 degrees of freedom in the numerator. And then how many degrees of freedom does it have in the denominator? Well, now you go down to the one above total, the 12 line, and it's always going to be the one above total. It's either the error line, if it's a within subjects one-way ANOVA, or the within line, if it is a between subjects one-way or between subjects factorial ANOVA. So this F ratio had 3 degrees of freedom in the numerator and 12 degrees of freedom in the denominator. Okay, next question I could ask you. The F ratio here is 1.44. There were 2 numbers in the chart that were divided to get 1.44. What was the number in the numerator? All right, well, the number in the numerator is going to be the one on in the mean square column that's on the same line as the F ratio. So the numerator of this F ratio is going to be 2.58. All right, what's the denominator of the F ratio? Well, that's going to be the one above the total line in the mean square column. It's either going to be error, like in this one, or within, if it was one of the between subjects ANOVAs. So the denominator was 1.79. So 2.58 in the numerator, 1.79 in the denominator equals 1.44. Way to think of it is, it's just the same thing in the mean square column that we did to get the degrees of freedom in the degrees of freedom column. This is the numerator degrees of freedom because this is the numerator of the F ratio. And this is the denominator degrees of freedom because this is the denominator of the F ratio. All right, last question. Mean square subjects. Mean square subjects. What two numbers in the chart did I divide to get mean square subjects? All right, so mean square subjects is 13.83. So remember, a mean square is always a sum of squares divided by degrees of freedom. So MS subjects 13.83, that's going to be SS subjects 55.3 divided by degrees of freedom subjects 4 is MS subjects 13.83. And that would be true of any of the numbers in the mean square column. So, for example, MS error is 1.79. And the way you get at 1.79 is it's 21.5 SS error divided by 12. DF error is MS error 1.79. All right, let's move up to the big leagues here and do a harder one. Next question for you is, what sort of ANOVA was done to generate this table? And the answer is, this is a between subjects factorial ANOVA. How do I know that? Well, it's got 5 lines. It's the most complicated. It has the interaction line here. That's also unique to the between subjects factorial ANOVA. None of the others have the interaction line. All right. So let's ask some other questions. How many levels did the age-independent variable have in this experiment? How many levels did the age-independent variable have in this experiment? Well, here's the line for the age main effect. So you go over the degrees of freedom. It says 2 degrees of freedom, so you add 1. And so the answer is 3. 3 levels of the age-independent variable. How many levels did the sex-independent variable have? Well, here's the sex main effect line. Go over to the degrees of freedom. It's 1, so you add 1. So 2 levels of the sex-independent variable. It'd be pretty weird if there weren't 2 levels of that one, I think. All right, so next question. Did I get a reliable interaction in the experiment? Did I get a reliable interaction in this experiment? Well, let's see. Here's the interaction line, right? The one with a little x between them. And I go over to the p-value, and that p-value is greater than 0.05. Greater than 0.05. So no, I did not get a reliable interaction in this experiment. Did I get a reliable age main effect in this experiment? All right, here's the line for the age main effect. Go over to the p-value. It's less than 0.05. And because it's less than 0.05, that means yes, I did get a reliable age main effect in the experiment. All right, next question. The F ratio for the sex main effect. F ratio for the sex main effect. How many degrees of freedom does the F ratio for the sex main effect have? So here's the F ratio for the sex main effect. How many degrees of freedom does it have? Well, how many in the numerator? Numerator degrees of freedom is going to be the one on the same line. That's 1. And then how many in the denominator? Well, that's going to be in the within line, the one above total. So that's 24. So this F ratio for the sex main effect, 1 degree of freedom in the numerator and 24 in the denominator. All right, how many degrees of freedom does the F ratio for the interaction have? How many degrees of freedom does the F ratio for the interaction have? All right, well, here's the interaction line. Here's the F ratio. So to get the numerator degrees of freedom, we go on the same line. And on the same line, that's 2. So it has 2 in the numerator. And then for the denominator degrees of freedom, we go to the line above the total line. That's 24. So 2 in the numerator, 24 in the denominator. That's the degrees of freedom for this F ratio. All right, next question. What two numbers in the chart were divided to get the F ratio for the age main effect? What two numbers in the chart were divided to get the F ratio for the age main effect? Okay, here's the age main effect line. We're going to go over to the F ratio, which is 89.20. So which two numbers in the chart were divided to get 89.20? Well, the numerator is going to be the one in the mean square column on the same line. So there's 1,672.5. That's the number in the numerator. And then the denominator is going to be the one above the total line, 18.75. So So 1672.5 divided by 18.75 is 89.20. Okay, which two numbers in the chart were divided to get the F ratio for the interaction? Well, here's the interaction line, and here's its F ratio, 0.31. So the number in the numerator is going to be the one in the mean square column on the same line as the F ratio, so that's 5.84. One in the denominator is going to be on the line above total, that's 18.75. So 5.84 divided by 18.75 is 0.31. All right, next question. What two numbers in the chart were divided to get MS within? What two numbers in the chart were divided to get MS within? All right, MS within is here, 18.75. And so remember, a mean square is always sum of squares divided by degrees of freedom. So 450.0, that's SS within, divided by 24, that's DF within, is equal to 18.75, that's MS within. What two numbers in the chart were divided to get mean square for the interaction? What two numbers in the chart were divided to get mean square for the interaction? All right, so here's mean square for the interaction. And so it's just going to be sum of squares for the interaction. That's 11.67 divided by degrees of freedom for the interaction. That's 2 equals the mean square for the interaction, 5.84. 11.67 divided by 2 is 5.84. Okay, so there'll be some questions like that on the test as well. Here we go. Let's take that away. All right. Well, I think we have done all the quizzing over the skills on the test. And so now we need to do quizzing on the other stuff that's on the test. So I'm going to, I didn't mean to do that. I'm going to get out the old review sheet. So this is going to be general quizzing about the rest of the review sheet like I do when we do the review sessions. So if you saw, the only new definition we have in the definition section was the response acquiescence effect. And the response acquiescence effect, if you'll recall, that's from survey research. That's the tendency of subjects to respond yes when they're presented with questions they've thought little about. So tendency of subjects to respond yes to questions they have thought little about, that is the response acquiescence effect. Okay, well, let me give you general quizzing. I'll pause a couple seconds and then give you the answer. So, first question. What term has the following definition? A tentative statement about the possible relationship between observable variables. Okay, that's a hypothesis. What term has the following definition? An explanation for a phenomenon that can be falsified and that involves entities that cannot be directly observed. That's a theory. Now we've got the forms of propositional logic that were not on midterm number 2, but they're back for the final. So let me ask you, I could ask on the final, what is the form of the argument modus ponens? What's the form of the argument modus ponens? And that is, if P is true, then Q is true. P is true, therefore Q is true. What is the argument affirming the consequent? The argument affirming the consequent, if P is true, then Q is true. Q is true, therefore P is true. That's the argument affirming the consequent. Now, another way I could ask those questions is, I could give you a particular example, and I ask you which form of propositional logic am I using. Let's try some of these. What form of propositional logic am I using in the following example? If it rains tomorrow, then the baseball game will be canceled. The baseball game was not canceled, therefore it did not rain. Okay, and that would be modus tollens. Modus tollens, if P is true, then Q is true. Q is not true, therefore P is not true. Okay, try this one. If it rains tomorrow, the baseball game will be canceled. It rained, therefore the baseball game was canceled. Okay, that's modus ponens. That's modus ponens. And now last one, if it rains tomorrow, then the baseball game will be canceled. The baseball game was canceled, therefore it rained. And that's modus tollens. That's modus tollens. Which form of propositional logic is most useful to science? That's modus tollens. Which form of propositional logic is valid but not useful to science? That's modus ponens. And then which form of propositional logic is invalid that we discussed? That's affirming the consequent. Okay, so those are what the questions will be like. I'll either ask you the form of the argument, or I'll give you an argument and ask you which one it is, or I'll ask you one of those three questions about the three forms of propositional logic, which one's most useful to science, which one is invalid, and which one is valid but not useful to science. All right, which term has the following definition? The specific values of the independent variable a researcher chooses to use in a study. And that's the levels of the independent variable. What advantage does the experimental approach have over other research techniques? The advantage is it allows the researcher to infer causation. Allows the researcher to infer causation. All right, we got the next set of things is those properties and types of scales of measurement. And we didn't have those on midterm 2, but they're back for the final. So let's review. Don't get them confused. The properties of the scales of measurement are identity, magnitude, equal intervals, and absolute zero. And then the types of scales of measurement are nominal, ordinal, interval, and ratio. So, first question I could ask you is, which of the properties of scales of measurement do interval scales possess? And the answer is the interval scales possess identity, magnitude, and equal intervals. Which properties of scales of measurement do ordinal scales possess? Ordinal scales possess identity and magnitude. Okay, so that would be one type of question I'd ask you about those. I'll give you a particular type of scale of measurement. You have to tell me which properties it has. The other type of question I could give you is I could give you a particular scale of measurement, and you would need to tell me what type of scale of measurement that is. So let's say I asked you for, if I'm using zip codes, what sort of scale of measurement is that? That would be a nominal scale. If I had class rankings, what sort of scale of measurement is that? Well, that's an ordinal scale. Any type of ranking is going to be an ordinal scale. What if I had Fahrenheit temperature? What type of scale of measurement is that? That's an interval scale, and the only two I could probably give you for interval scale are Fahrenheit and Celsius temperature, so that's about the only ones I could give you for that one. And then let's say I had weight in pounds. What sort of measurement scale is that? Well, that would be on a ratio scale. Weight in pounds is a ratio scale. So those are the two types of questions I would ask you about the types and properties of scales of measurement. I could give you a particular type of scale, and you have to list the properties. Or I could give you a particular scale of measurement, and you have to tell me what type it is. All right, what term has the following definition? Occurs when, after the subjects who are going to be in the experiment have been chosen, each subject has an equally likely chance to be assigned to each IV level in a between subjects design, or to each treatment order in a within subjects design. And the answer is, that's random assignment. Random assignment. What term has the following definition? Occurs when every member of the population to which we would like to generalize our results has an equally likely chance of being chosen to participate in the research. And that's random selection. That's random selection, or random sampling if you prefer. Which is more important for internal validity, random assignment or random selection? I would say random assignment for internal validity. What's more important for external validity, random selection or random assignment? I would say random selection is more important for external validity. What term has the following definition? A research technique in which the researcher manipulates the independent variable on which subjects have not been randomly assigned. That's a quasi-experiment. Another question I could ask you about that is, what does an experiment have that a quasi-experiment does not have? And that's random assignment. What term has the following definition? A graph showing the number of times each score occurred in a data set. That is a frequency distribution. Which is greater in a negatively skewed distribution, the median or the mean? In a negatively skewed distribution, the median is greater than the mean. What is the relationship between the mean and the median in a positively skewed distribution? In a positively skewed distribution, the mean is greater than the median. Way to remember that is the mean is always closer to the tail than the median is. So in a negatively skewed distribution where the tail points towards the smaller numbers, the mean is going to be smaller than the median. In a positively skewed distribution where the tail points towards the bigger numbers, then the mean is going to be greater than the median there. Which one gives more consistent results across repeated samples? The mean or the median? Answer is the mean. That's why we do our statistical tests on the mean, because it's more consistent. Which one is more affected by extreme scores, the mean or the median? The mean is more affected by extreme scores. Which one is easier to calculate if you have 1,000 scores? And the mean is easier to calculate if you have 1,000 scores. What are 3 problems with within subjects designs that are not problems in between subjects designs? 3 problems in within subjects designs that are not problems in between subjects designs are practice effects, sensitization effects, and carryover effects. Practice effects, sensitization effects, and carryover effects. What term has the following definition? Occurs when the effects of one treatment persist when another treatment is introduced. That's carryover effects. What term has the following definition? Occurs when the subject's performance on the experimental task changes either for better or worse as a result of experience with the task. That is practice effects. What problem does a Latin square solve? Problem it solves is practice effects. Latin square is a method of doing counterbalancing that solves for practice effects. What term has the following definition? A method of assigning subjects to treatment orders and within subjects design such that across subjects practice effects are canceled out. That is counterbalancing. What term has the following definition? The extent to which your research provides a valid test of the relationship between the independent and dependent variables. That is internal validity. Okay, if I increase alpha in an experiment, what effect does that have on statistical power? If you increase alpha in an experiment, that will increase the statistical power of the experiment. If you increase statistical power in an experiment, what effect would that have on beta? If you increase power, then beta, that's the probability of making a type 2 error, is lowered. Beta is lowered. So, if you increase alpha in an experiment, what happens to beta? If you increase alpha, then beta will go down. Increasing alpha decreases beta. Why is it desirable for an experiment to have high statistical power? It prevents type 2 errors. That's why it's desirable for an experiment to have high statistical power. What term has the following definition? It is logically impossible to show that an independent variable has no effect on a dependent variable. And that is can't prove the null hypothesis. What term has the following definition? The tendency for extreme values of a variable to fall closer to the group mean when retested. That is regression to the mean. Regression to the mean. Okay, there's a section that says, or one item on the review sheet says, be able to explain how the logic of experimentation is ruined by confounds. So the shortest correct answer I would take to how is the logic of experimentation ruined by confounds would say, if you have a confound in your experiment, it is impossible to know whether it was the IV or the confound that influenced the DV. If you have a confound in your experiment, then it is impossible to know whether it was the IV or the confound that influenced the DV. What term has the following definition? The extent to which the results of your research can be applied outside the research situation. That is external validity. External validity. Okay, I'm going to give you some definitions that are very close to one another, so listen carefully. What term has the following definition? Occurs when subjects become aware of the manipulations used in a study, and such awareness causes them to change their behavior. That is sensitization effects. Sensitization effects. What term has the following definition? Aspects of a study that indicate to subjects how they're expected to respond. That is demand characteristics. Demand characteristics. Next question. What about when subjects change their behavior because they know they're being observed? That is the Hawthorne effect. That is the Hawthorne effect. What about when subjects change their behavior as a result of their expectation that change should occur? That's placebo effects. Placebo effects. What about when subjects change their behavior due to unintentional cues from the researcher? That's Rosenthal effects or experimenter expectancy effects, whichever one you prefer. What is it called when an IV influences a DV only because the IV is something new? And that's a novelty effect. That's a novelty effect. What is a naturalistic observation in which the researcher becomes a member of the group being observed? That is participant observation. That's participant observation. What problem does a single blind study solve? A single blind study solves placebo effects. What two problems does a double-blind study solve? A double-blind study solves placebo effects and Rosenthal effects. What does MS Treat measure in a between subjects one-way ANOVA? MS Treat measures the variability in the DV due to the IV and error. MS Treat measures the variability in the DV due to the IV and error. What does MS Within measure in a between subjects one-way ANOVA? MS Within measures the variability in the DV due only to error. What does F measure in a between subjects one-way ANOVA? F measures how many times greater MS Treat is than MS Within, or you could say F measures whether the IV has an effect on the DV. Both would be fine. What term has the following definition? A within subjects design in which a single group of subjects is tested on the dependent variable both before and after some experimental treatment. That is a time series design. And remember, you know two time series designs. The single group pretest post-test design is a time series design, and the interrupted time series design is a time series design. What term has the following definition? A statistic used to measure the direction and strength of the linear relationship between two variables. That is the correlation coefficient. That's the correlation coefficient. What is the largest a correlation coefficient could ever be? Largest it could be is +1. What is the smallest that a correlation could ever be? And the smallest it could ever be is -1. Smallest is -1. What's it called when as one variable decreases, another variable also tends to decrease? Okay, that's called a positive relationship because both variables are moving in the same direction. The way I put it, as one variable decreases, the other variable tends to decrease. That is logically equivalent to saying as one variable increases, the other one tends to increase. Key thing about a positive relationship is the two variables are moving in the same direction in a positive relationship. What's it called when as one variable decreases, the other variable tends to increase? Well, that would be a negative relationship because the variables are moving in opposite directions. If the correlation between the car's gas mileage and its weight is -0.6, what is the proportion of variance accounted for in gas mileage by weight if the correlation is -0.6 again? The answer is 0.36. 0.36. So if on the test it asks you for a proportion of variance, make sure you don't give the percentage. Don't multiply it by 100, just give it 0.36. And remember, when you square a negative, it becomes positive. So it's impossible for a proportion of variance accounted for to ever be negative. It always has to be positive, and it always has to be a number between 0 and 1 inclusive. Let's try another one. What if the correlation between a car's weight and its gas mileage is -0.2? What is the proportion of variance accounted for in gas mileage by weight? And the answer is -0.2 squared, which would be positive 0.04. Positive 0.04. What term has the following definition? Occurs when there is a floor or a ceiling effect on one of the variables in a correlation. That is range restriction. Range restriction. What term has the following definition? A class of statistical tests that make assumptions, particularly normality, about the distribution of the dependent variable. Okay, that's parametric statistical tests. And this is the new stuff that we haven't had before. That was parametric statistical tests, and I'll tell you the definition again. That is a class of statistical tests that assume the dependent variable is normally distributed. That would be a perfectly fine definition of that. All right, next question is, know the mathematical relationship between the T and F distributions. That's a little bit tough to put down here, but I'm going to put it. So the mathematical relationship between the T and F distributions is T with x degrees of freedom squared. What I'm going to have to do is, well, just wait a second, equals F with 1 comma x. And this is true at any alpha level. Let's make this character. All right. T with x degrees of freedom squared equals F with 1 comma x degrees of freedom. And that's true for any x at any alpha level. So this is what I would remember if I were you. T with x degrees of freedom squared equals F with 1 comma x. That is the mathematical relationship between the T and F distributions. What is a type of research in which data is collected by directly asking subjects questions? And that is survey research. That's survey research. What is the best use of surveys according to me, the instructor? What's the best use of surveys according to me, the instructor? And the answer is to compare changes in responses over time or across different demographic groups. To compare changes in responses over time or across different demographic groups. I'm going to ask you some questions about the sections of a manuscript. I'm going to give you a piece of information or a description of the section. You have to tell me what section I'm talking about. Okay, here we go. What section would I find on page 2 of the manuscript? Answer is that's the abstract. What section would I find on page 3 of the manuscript? That is the introduction. Where would I find in the manuscript the author's affiliation? Find the author's affiliation on the title page. Which section of the manuscript is usually divided into 3 subsections? Well, that's the method. The method is usually divided into 3 subsections. Which section of the manuscript would have ideas for future research? Yeah, that's a discussion section would have ideas for future research. In which section of the manuscript would I find a graph showing me the means of the dependent variable at each level of the independent variable? That's the results section. What section of the manuscript would I find out what statistical tests were performed on the data? That's also the results section. I'm going to try and get you to say method on that, but that's wrong. Remember, we talked about in that lecture how you don't talk about the statistical tests until the results section. So if I ask you what statistical tests were performed on the data, you say results, not method. In what section of the paper would I find the literature review? That's the introduction. In what section of the paper would I find out how many subjects were run in the experiment? And that would be the method. So that's what the questions are going to be like about the sections. I'll give you like some kind of description of the section, like what page it's on, or some information you could find in the section, and you have to tell me which section I'm talking about. What term has the following definition? A typeset copy of the article that is sent to the author for final approval. Those are galley proofs. What term has the following definition? The status of an article that has been accepted for publication, but which has not yet appeared in the journal. And that is in press. That's in press. Okay. How does the Nuremberg Code of Ethics differ from the APA Code of Ethics? The APA Code of Ethics allows certain forms of deceit or coercion to be applied to potential research subjects. The APA Code, not the Nuremberg Code, allows certain forms of deceit or coercion to be applied to potential research subjects. Okay, well, we went through most of the general section here. Now I'm going to ask you the lists that you need to know. Starting with my favorite one. What are the 5 factors determining statistical power? Well, the way to remember that is with the acronym CAVES, C-A-V-E-S. Each letter stands for a different one of the 5 factors. So C stands for correlation between the IV levels. A is alpha. V is variability in the DV. E is effect size. And S is sample size. Why would you want to do an ANOVA to test the means instead of multiple t-tests when you have more than 2 levels of the independent variable? First is that an ANOVA is less work, and the second is that multiple t-tests inflate the type 1 error rate. Multiple t-tests inflate the type 1 error rate. What are 2 reasons why correlation cannot be used to determine causation? Okay, first is the directionality problem. It's sometimes unclear which variable is cause and which is effect. The second reason is the third variable problem. There may be a third unmeasured variable that's responsible for the relationship. What are the three mathematical limitations of correlations that we discussed in class? The first is that they're poor at capturing non-linear relationships. The second is they're greatly affected by extreme scores. And the third is that they can be lowered by range restriction. What are the two advantages of non-parametric statistics we discussed in class? The first is they have less restrictive assumptions, and the second is they're often easier to calculate than the parametric equivalent. So that's one of the two advantages of non-parametric statistics. They have less restrictive assumptions, and they're often easier to calculate. The disadvantages, what are the disadvantages of non-parametric statistics? The disadvantages of non-parametric statistics are, first, they tend to be overly conservative, and secondly, no non-parametric tests exist for some research designs. Now, the factors to consider when evaluating polls, we had 8 of them, but you only need to know 3, and any 3 you want to know is fine. Here's the way I remember my 3. I have a little rhyme, or I don't know if it doesn't rhyme, a little thing I do to remember them. It goes like this. Question, wording, question, order, type of question asked. Question, wording, question, order, type of question asked. Question, wording, question, order, type of question asked. So if you want to remember that little rhyme, question, wording, question, order, type of question asked. That would be fine. You can remember it that way. But we had 5 others as well that you could also remember. So any of those would be fine. Okay, what are the 4 problems with all single subject experimental designs? Okay, the 4 problems are 1, likely placebo effects, 2, likely type 1 and type 2 errors, 3, experimenter bias, and 4, generalization difficulties. All right, last thing you need to know are the ethical principles when conducting psychological research. You can know any 4 of those, and so we had the last 2 lectures, and you should go to those. So that's first, subjects should agree to participate in research. Subjects should not be coerced into participation. Subjects should be fully informed about the nature of the experiment. In experiments involving deception, the subjects should be informed about the nature of the deception at the end of the study. The gains to science should outweigh any harm done to the subjects. The subjects should be fully informed of any hazards that are present during the experiment. All subject data should remain confidential, and all reports of the data must be accurate. Whatever 4 it's easiest for you to remember, those are the 4 you should do. So, remember, there will be no determining main effects and interactions in graphs and tables. So we learned how to do that in class, but I don't know any way to put it up on the Canvas site for the test. So we won't be doing that. So I think that's it. I think we went over everything that could possibly be on the test. Gosh, I'm sorry again that we had to do things this way. This is the last time I'm ever going to get to talk to you. So I hope you all have good and happy lives. If I'd ever see you again, and I sure enjoyed having you in class when we did, and who knows, maybe I'll see some of you someday next semester, I hope. So good luck on the test, and we'll get the test up soon, and you have a great summer. Bye-bye, everybody.